solve systems of linear equations. And this is going on page 31 when we're done. So I want you to think about, without speaking, what is a system of equations? And I'm going to call on somebody to give me that answer. And that would be Cameron. Where's Cameron? All right. So what is a system of equations? Just you don't have to use fancy math language, just describe it to me. Okay, it can get to that. It can get one equation equals another equation. That it can get to that point eventually, but we don't really start that way. So, what do you think? Look down. There's an example of one down on the front of your notes there. How could you describe that to me? Okay. Okay, there's two equations. Okay, there's two equations, and then there's what? Two equations and two. Your name is not Kim. Like, would my two equations be like 3x plus 7 equals 10 and 4x minus 3 equals 20? Two variables. Good. Two equations and two variables. Is that how most of you would think about a system? Okay. So that's probably the only way that you have seen a system so far. But just so that you know, a system of equations could be 3 equations, 3 variables, 4 equations, 4 variables. All right, however many equations you have, or how many variables you have to have at least that many equations to be able to actually solve for it and get a value and not have something with some other variables in it. All right, so that is your system of equations. All right, good. So thank you, Cameron. Now we can solve the systems of equations a few different ways. So I want you to think about what those different ways are. Give me one way I can solve them. Jose. What's one way to solve a system of equations? Well, if you look at the notes that are right in front of you that we haven't even talked about yet, I bet you could remember something. And if we actually did the summer assignment, and we would know too, because you got to do them. So what's one way? Look at the words that are on the paper in front of you. You see that system down at the bottom? Read that right. Read the instructions right above it. Okay, substitution. That's one way. So another way. Maribella, where are you? Y'all did take Algebra 1 last year, right? Yeah. We all did do the summer assignment, right? Yeah. You know that this right here, 100% review. Elimination. You are good. Elimination. You already need to be rock stars at all of these things. One more way that you did it in Algebra 1. Nathan, where's Nathan? Not on there. Paper's not going to help you on this one. Sorry, you're out of luck. What's the other way you did it? Well, that's something that you have to do within one of these, but you graph it. Good. So substitution, elimination, graphing. Those are 3 ways that you have done solved systems of equations in Algebra 1. All right, so we are going to list those out. We can solve systems of equations by graphing. In here, though, we are not doing it by graphing. This is really just for the calculator from here on out, but we're not even going to get to that point. Because when you do it by graphing, you've got to graph 2 things, and then you look at where they intersect, and you've got to pull that point off the graph. Well, that's because you got nice, pretty numbers on things. Really, when you're pulling points off of graphs now, that's kind of just guessing off a graph, and that's not okay. We never assume anything. So just because it might look like the point's at 5.3, it might really be at 4.987, 836 or whatever, and you don't know that, so you can't just assume that you're going to get whole numbers there. So that's kind of, you'll do more of that in Algebra 2 again. We probably won't even look at that on a calculator in here. But then the substitution, elimination. And then you can also solve them with matrices. Okay? And that is just plural for matrix. That is not something that you would have done at this point, most likely. I would highly doubt that you have, but I do want you to know there are other things that you haven't learned yet. Though the matrices come in handy when you do have 4 equations, 4 variables, because you could still do substitution and elimination. It's just going to take you a lot longer because you got to keep going back through the process, where matrices is going to help you get through it a whole lot quicker. Okay, so let's talk about, we're going to kind of give you the step-by-step here on what to do. Step 1 is the most important step, and step 1 is the type of thing that is going to hinder some of you even when you have excellent algebra skills. Because just because you have excellent algebra skills doesn't mean you know when to apply them. And that's what a lot of you are going to struggle with. Okay, it's not necessarily that you can't do this stuff, it's that you don't really know when you're supposed to do what. And that's a tough thing, but that's something that you got to make sure that you get figured out. So as silly as it may sound, your very first step here is to identify as a system. Because if you don't even know that that's what you have in front of you, you don't know that you need to do substitution or elimination, which are really your only 2 options right now. Okay? If I tell you solve these systems, and that word systems is in your brain, then that may help. But if a system, you have to set up a system within something that we're doing, which is the reason that we're reviewing this, then if you just stare at it and you're like, I don't have a clue what to do, that's a problem. If somebody's saying the word system and you don't think about that, so it takes some people a while, just tell me it's a system. Once you know it's a system, bam, you know what to do with it. Okay, so you got to be able to know that's what you have without somebody telling you. So if we're going to do by substitution, you identify it as a system, you pick one equation, and one of that equation's variables. So I might pick the second equation, and I'm going to solve for x. Okay, so another one of the reasons that we're going through this is I want to make sure that you understand it doesn't matter which equation, and it doesn't matter which variable. Okay, and it doesn't have to be both of them. And that's where some of you try and do things the hard way. So the words that were coming out of your mouth, Cameron, are things that I know other people are thinking and would do, and a lot of times you're making it harder on yourself. Do you have to always take both of them and solve them for y? No. And then do you have to solve both of them to set them equal to each other? No. Can you do that? Yes, you absolutely can, but you really might be making your life a whole lot harder. So hopefully it's not the way that you were taught to do that. I think sometimes there's just, if you don't do a whole lot of examples, or if they all kind of work out that way, then you start to kind of assume those things. But I do see that a lot, that you feel like it has to be y that I solve for. And I'm going to solve them both so that I can just substitute that part in. And that's, you don't have to do that. It may work out that it's easiest to do that way, but a lot of times you're making it harder on yourself. So you pick one. Whichever one would make your life the easiest. Sometimes you may not even know, so you just pick pick whichever one. But usually you can tell that one might be better than the other. All right, so once you've picked that, so let's say we pick the second equation in x, then we are going to solve for the variable you picked. Okay, so we solve for whatever that is. So now you have at least one of them solved for a variable. It does not have to be both of them. Then you substitute the expression from step 2 into the other equation of the system. So the other one. Don't substitute back in the one you just manipulated, because then you're just going in circles. You're not getting anywhere. So make sure it's the other one. So now you just have one variable left, so now you solve for that variable. So now you're done, and you get like x equals 5, or whatever it is. Then you take that, and you substitute the value from step 5 into either one of the original, I'll put a little star there, because we'll come back and talk about that. Either one of the original equations. So now once again you just have one variable left, so you solve for the remaining variable. So you have x equals 5, y equals 2, or whatever it is, and then you should always write your answer as what? Ordered pair. Good. And I said always, but it's always if it's pure math, like if it's just this and you're solving the system, or if it makes sense to be an ordered pair. If it's a real-world situation, an ordered pair may not make any sense at all. If you're not using X and Y, if you're using A and B, then do you really know which one's X and which one's Y? So there are real-world situations and stuff where the ordered pair doesn't make sense, but if it's just pure math and you're not applying it to anything, then it should be an ordered pair. Okay, so we're going to solve this by substitution. Now, beyond this assignment, because on this assignment it will say, solve these by substitution, solve these by elimination. But beyond that, you get to decide which one's the best. Okay, because sometimes you can look at a system and know that one is better than the other or easier, or maybe you have a preference. That's okay. I'm not going to force you to do it specific ways, except for this first assignment so that I know that you know how to do both. And then past that, you can do what you want. So I'm going to do this by substitution. If I picked the second equation and I wanted to solve for either X or Y, would that be my best decision? No, because whether I solve for X or Y in the second one, I get fractions, right? And so that's another reason why I wouldn't want to solve them both for a variable, because I don't have to, and either one of the variables I pick on this one right here, it's just going to be yucky, right? So even if it might work out on some, I probably don't want to do this on this one. But I will have people that no matter how many times I say that, will still do that. And it's ugly. You make your life more difficult, and then things just get super messy in there. So I'm going to pick the first one, and I'm going to solve for Y, because I'm pretty sure that's the easiest one, right? And this is not a proof, so I don't have to show every single step. So I can move Y over here and 11 over here all at the same time and get 3x minus 11 equals Y. So then my next step is to take that expression that I got here and plug it into the other equation. So that's equal to Y. I'm plugging it in here for Y. All right, I'm going to substitute it in there. Make sure if you plug it back into this one, you're just going to go in a vicious circle. So this gives me 5 times 3x minus 11 minus 7x equals 1. Even if it's easy and you are capable of simplifying things before you write it down, you do not do that. First step, 0 work, plug it in. Okay, that shows process. Then it's going to give me 15x minus 55 minus 7x equals 1. 8x equals 56. What does x equal? 7. Okay. So then I take this, and what the little steps say up there is you plug it back into either one of the original ones. Well, these two are my original ones. This one isn't original because I manipulated it. But could I plug 7 in here and still find x okay? Yeah. You just don't want to plug it back into here, which every now and then I see. It's really scary. Of these three, wouldn't you say this one's probably the easiest? So even though it's not really the original one, it's also not one where I lost a variable. So I'm going to take this, and I'm going to plug it in here for x. So this is going to give me 3 times x. Oops. Well, I need to actually substitute x in. 7, yeah. Okay, 3 times 7 is what I meant to do. Minus 11 equals y. Again, I know you know 3 times 7 is 21. At least you should. But I'm not writing 21 here. You actually show your process. Okay, so then 21 minus 11 is 10. So y equals 10. Am I done? No, I need to write it as an ordered pair, and then please don't do all the work and then not write them in the right order, because holy cow, we should know how to do x and y. Okay. Any questions? We're all good? Total review. Should be able to do that easily without me, but I just want to make sure that we're all on the same page here. Okay, next one. So when you look at this example, what is it about this that you don't like? Fractions. Okay, you're going to have to get over that real quick, okay? Because you never change a fraction to a decimal, like ever. I know you might think that that's the easier way to do it. I'm going to change it to a decimal, do my thing, and change it back. No, you're making your life way harder. That's not going to work here anyway, because 1/3 is going to be a repeating decimal, and that little line over it ain't going to do nothing for you, okay? Calculator not going to help you either, because you're not going to get one in your hand. Plus, if I don't drill the fractions in your brain like your 4th grade teacher should have, and every teacher until now, you're never going to make it through Algebra 2. Because even if the fractions that we have, because most of them will have numbers, you may be able to manipulate them on a calculator when you're not in here. In Algebra 2, your fractions are going to have expressions in them. And if you don't know how to add, subtract, multiply, and divide fractions, that calculator is not going to do anything for you because they're a bunch of variables. You have to know when you need to flip and when you need to get a common denominator and all those kinds of things. So if you don't know your basic 4th grade fraction rules, add, subtract, multiply, divide, you need to go Google it, do some drill and practice, and become rock stars at fractions. Because I will make you a believer pretty soon that it's better than the decimals anyway. So, but you've got to know that stuff. You can't avoid it. Now, if I mean, I'm not afraid of fractions, but when I'm choosing my equations, I still wouldn't choose why would I choose the first one and solve for x? That's ridiculous when I could choose the second one. So I'm not saying you have to choose that one, but you can't always avoid them at all costs. Like I know some of you have since the first day somebody tried to teach them to you. All right, so I would say let's definitely choose the second one, right? And I'll solve for x because that's easier here. So x equals y plus 2. So then I'm going to take this, I'm going to plug it in for x. So I get 1/2 times y plus 2 plus 1/3 y equals 6. So now I have to distribute. What's 1/2 times y? 1/2 y. What's 1/2 times 2? 1. Oh, maybe y'all are right. Those fractions are so hard. I don't even know how we made it through there. See, you all survived. If you're trying to tell me that's hard, that's just ridiculous. Plus 1/3 y equals 6. Okay? So now I have to add them. When you add fractions, what do you have to have? Common denominator. All right? What would my common denominator here be? 6. So I'm going to have to multiply this one by 3 over 3, so that's going to give me 3 over 6. Multiply this one by 2 over 2, so it's going to give me 2 over 6. So I now have 3/6 plus 2/6. What is that? 5/6. 5/6 y equals 5. Okay. Then I need to get y by itself. Okay. Because it's, okay, let's back up here because you all are both right. 5/6 is being multiplied by y. The opposite of multiplication is division. So I'm going to divide by 5/6. But when you divide by a fraction, what do? You multiply by the reciprocal. So yes, you're dividing, but then your dividing turns into the multiplying by the reciprocal. So I'm going to multiply both sides by 6 over 5. Right? These cancel out. That's the whole reason that you did it. When you multiply a whole number times a fraction, it would be very helpful to put it over 1 so you don't go do something weird. Do you have to have a common denominator? No. So you can multiply and get 30 over 5, or these cancel out and you just get y equals 6. Okay. All right, so then I take that and I'm going to plug it in to y right there. So I'm going to get that x equals 6 plus 2. I know you know 6 plus 2 is 8, but again, it's a process. That could be a point on an AP exam. I know it sounds ridiculous, but it's the truth. Okay? And because what you're showing is not that just 8 popped into your head somewhere, but that you actually took that and put it in there. Okay? So even when it seems ridiculous, remember, your opinion doesn't matter, my opinion doesn't matter, it's just how it is. So x equals 8. And then write it as an ordered pair. I get 8, 6. Okay? Those fractions were not that bad. You cannot see it and you can't freak out just because you see fractions. You have the ability to handle them, and you need to be able to do that, or you won't survive past geometry in life. Okay. Let's look at this one. It says, at the school store, Juanita bought 2 books and a backpack for a total of $26 before tax. Each book costs $8 less than the backpack. What's the price of each book and each backpack? Write a system and solve. Okay, so I'm going to give you a couple minutes. I want you to write the system of equations. I don't want you to solve it yet. I just want you to get your system written. Raise your hand if the variables you used in your system are x and y. Okay, raise your hand if you used something other than x and y. Okay. All right, so tell me, what 2 variables did you use? B and D? Okay, so tell me why you chose B and D. Okay, because you couldn't use 2 B's. Okay, what did you use? B and P? That's exactly what I did. What did you do? B and A? Okay. You did A, I guess, for like backpack day. Okay. And then last period I had, what did somebody do? They did A and O for, I guess, the O in the book and A in backpack. O is a dangerous one, though, because it looks like a 0. And the other one did C and K because backpack has a C in it and book doesn't, okay? Now, do you have to use letters other than X and Y? No, you don't. If it's a word problem and you want to because it makes sense for the words, that's totally fine. Do they have to be the same as everybody else's? No. Now, if you used X and Y, did you define what X and Y are? Okay? If you did not, that could become a big problem for you, right? Because once you solve it, you got X and Y. Does an ordered pair make sense in this case? No, it doesn't. And if you, when you're done and you've got, X equals 5, Y equals 2, you're not going to know which is which unless you define it, okay? So personally, I usually use letters that make sense in the word problem because I'm too lazy to define it. And I know if I don't define it, then when I finish, I won't remember which is which, okay? So that's fine. X and Y, fine. Just make sure you define what it is. Whatever other letters you use, as long as it makes sense to you so you know what's what, and it would probably make sense to somebody else that looked at it, then that's fine too, okay? But you've just got to make sure you know what you have in the end. Because there's lots of times, not just on stuff like this, y'all get an answer, you're like, X equals 5. Okay, what is 5? Is it 5 miles, 5 hours, 5 years? I'm like, I don't know. Well, that's a problem. You don't even know what you're doing. You're just doing stuff, and that's not getting you anywhere. So if whatever letters you used are fine. I'm not going to use the same letters. Well, I am as somebody, but I don't remember his name. What's your name? What is it? Oh, Nicholas. So Nicholas and I are on the same page because I did what he did. But whatever you have is fine. You don't have to change it to mine, okay? So let's just look at our equations. At the school store, Juanita bought 2 books and a backpack for a total of $26. So this is what happened the first time I worked this problem. I said, okay, so 2 books plus, and then I went, oh crap, backpack starts with a B too. So that's when I went with P. So 2 books and a backpack equals $26. If I'd have thought ahead, maybe I'd have done something different, or maybe I thought that was fine too. Then each book costs $8 less than the backpack. So here's the other thing I want to make sure you understand from word problems. Most of you, probably all of you, are in a foreign language, and if it's on this campus, it's either Spanish or French. When you translate stuff back and forth from English to either Spanish or French or one of the Romance languages, do things seem backwards? Like if I translated a sentence word for word, it probably wouldn't make a whole lot of sense in the other language, right? So English is the backwards language. Not Spanish, not French, and not math. Math is a language of its own also. So when you have a word problem and you're translating it and trying to write an equation, because that's all you're doing is translating from one language to another, you have to be careful when you're trying to do it word for word, because that's when things don't work out. Because when I read this, $8 less than a backpack, well, less implies subtraction. So is it 8 minus a backpack? No. And that's pretty simple for you to kind of think about, but just remember that in other things that you're doing. English is backwards, so you have to take the context into consideration. All right, so each book, so a book, I'm not pushing the button. The book is $8 less than the backpack, so it's a backpack minus 8. So regardless of what variables you used, you should look something like this, yes? Okay, awesome. So now we do substitution. It's already solved, right? I don't even have to do anything else. So got this. I'm going to put this into B. So I'm going to get 2 times P minus 8 plus P equals 26. So 2P minus 16 is P equals 26. And so 3P equals, what's 26 plus 16? 42. Do 26 plus 10, that's 36, plus another 6, that's where you get your 42 from. Then what's 42 divided by 3? 14. So P is equal to 14. So then I've got to take this and I plug it in here. You actually write it down, even though it may seem ridiculous. 14 minus 8, which means B equals 6. Or X or Y or whatever letter you used, right? But whatever letters you used, this 6 should represent your books, and the 14 should represent your backpacks. So does an ordered pair make sense here? No. Because how many of you use X for backpacks? Anybody? A couple of people? Okay. So most people use X for books because it came first. But do you have to? No, you could use X for backpacks. It doesn't matter. So in the end, an ordered pair doesn't matter. But you can't leave it like this, because nobody said solve for B, solve for P, right? I also didn't tell you solve for X and Y. The question asks how much these things cost. So then we have to say books books cost $6 and backpacks cost $14. Like, you have to answer the question. Don't just leave it as B equals 6 or whatever it is. Okay? Any questions? You good? Huh? Okay, sorry. Oh, yeah, probably. That's fine. On an AP exam, and what I really should be training y'all to do is they want complete sentences. But at this point, honestly, I'm just glad when I get some words, so we kind of work towards that. Okay? All right. Anything else? That's a good question. All right. Then let's move on to elimination. So elimination is a different way to solve systems. Your step 1 is the same. What do you think it is? Identify. You have to be able to look at it and say, hey, that's a system of equations. And that is going to be the toughest part for some people. So you have to identify it as a system. So now we pick a term. Either, and I'm going to put the X term with a little star or the Y term. And I'm putting the little stars there because we just talked about the fact that it doesn't have to be X or Y. So I should probably reword that sentence, but you know what I mean by that. So you pick one that you want to eliminate. And does it always have to be X or Y? No, you pick whichever one is the easiest to do that makes your life the easiest. Then you multiply, if necessary, sometimes you're lucky and it's not necessary, one or both equations, each by the number that will zero out the term. Good. You need to know how to do both because there are times where one is a lot easier than the other and vice versa, okay? All right, so then once you do that, then you vertically combine like terms. And what I find is that sometimes you have a preference because your teacher let you choose, and sometimes the reason you have that preference is because that's what your teacher liked the most and that's what they did the most. But you really need to be familiar with both because there's reasons you need to be able to do both. So once you vertically combine like terms, that one should be zeroed out left to the variable. So once again, part where you're like x equals 5 or whatever it is. So now the rest of the steps are pretty much just like substitution. So you take what you have, you substitute the variable from step 5 into either one of the original equations. And again, put a little star there. In this case, you probably do want the original ones. So then again, you have one variable left, so you solve for the variable, and then you write the solution as an ordered pair. So again, once you're past this assignment, you'll be able to choose which way you want to do it. But even if I got to choose on this one, I don't think substitution is what I would choose because no matter which equation and which variable I choose, I would have to get a fraction. And so, like I said, you can't always avoid fractions. I can avoid it here, though, by doing elimination, which is the way we're going to do it anyway. So we're going to do elimination. Which term do you want to eliminate, X or Y? Okay. X maybe because the numbers are smaller, right? There's nothing wrong with Y. It's not like those numbers are huge. Which one's the best is a matter of opinion. So you can do it as long as you do it right. It doesn't matter. So let's pick X. The numbers are smaller. And so then basically what you're trying to do is the same kind of thing when you're looking for a common denominator. So what number am I going to have to get here? 6. So I'm going to have to multiply both of them. So I multiply the top one by 3. The bottom one by 2, and remember that you also have to have an opposite sign. That's already taken care of for you, so you don't have to worry about it. Make sure you multiply by every single thing you have there. So this is going to give you 6x plus 15y equals, oh my God, I don't have a calculator, right? You're like crying to yourself right now. What's 3 times 20? 60. 3 times 20 is 60. 3 times 6 is 18. So 60 and 18 is 78. There you go. See, you don't need a calculator. All right. 2 times negative 3x, negative 6x. Oh, not plus, sorry. I could have done plus a negative, but minus 8y equals negative 50. Okay, so now you have just a big old addition problem, right? When you vertically combine, one of the sets of terms should cancel each other out. If they don't, then you did all this for nothing, because then you're just making other things weird. So those cancel out. That leaves you with 7y equals 28, which means y equals 4. Okay? So then you plug it back into either one. Now in this case, there's 4 choices. Because I just made these numbers bigger, these probably aren't the best choice. If you do it correctly, it's fine, but I don't know why you'd want to make your life more difficult. So over here, would you pick the first or second one? First one's way safer, right? Because you don't have to worry about all the negatives. So this is 2x plus 5 times 4. You do not write 20 right there yet. Equals 26. So 2x plus 20 equals 26. 2x equals 6, and x equals 3. Which means this is just a pure system, so I write it as an ordered pair. 3, 4. So you need to be able to solve them. You need to be able to write them and solve them. All that is a review. Just want to make sure that you understand that the thing that I think worries me the most about all that is just with substitution, some people always picking y and always solving both of them, and that is not necessary. It makes it a lot harder.